So up here first, we discussed on the sideboard, but we're gonna put it up here for us. N, I'm gonna write this out over here. NPR. This is the total number, correct? This is how many we are picking. And this means order matters. And we talked about that. If it's a permutation, if you're picked first, second, third, or fourth, makes a difference, right? Different jobs, different occupations, right? Different trips you could go on, have your permutation. The C happens when order doesn't matter. If you picked first, second, third, fourth, you get the same outcome. Okay? All right, we're skipping number 4 for now. We're going to go to number 5. This formula, if this is the total number and this is how many you're picking, could we ever do this? Could we go 4, permutation, order 5 objects? Could we ever do that? I had someone on a test, on a diploma, call in someone, and they're like, my calculator does not work. Can I have a new one? Well, what they were doing is they were plugging in the numbers backwards the entire time. They were going 4P5. Instead of 5P4. 4P5 will never give you an answer. You're saying, I have 4 objects, I'm picking 5. Can you do that? Can you have 4 objects, pick 5? Can you have 4 people on a committee and pick 5 for a subcommittee? Does that even make sense? So if this is a 4, at max, what could this number be? Even higher. 4. Could I have 4 people on a committee and pick 4 for a subcommittee? That'd be really stupid. It's still the committee. But could I do that? Yeah. And give them jobs? Yeah. So that's the key thing here. For this R here, it says R has to be less than or equal to N. Always. So NPR, R has to be less than or equal to N, which makes sense. If N is 20, then I can pick 20 or less from it. We agree? Okay. So our formula is this for NPR. It says algebraically solve. So if I went and said, oh, okay, N, I know that N has this number over here, this N minus 1, has to be 2 or higher, correct? So N would have to be 3 or higher, technically, because 3 minus 1 is 2. Like this has to be 2 or greater. So I could plug in, that has to be 2 or greater, so N would have to be 3 or greater. So I could go 3P2, 4P2, 5P2, 6P2, 7P2, and I could get the one that gets me 90, correct? If it didn't say algebraically, cool, you'd get an answer, you get a mark. If you do that and it says algebraically, you are getting big old goose egg. Algebraically means you need to show algebra. If you do not, and you just give an answer, they don't give you 0.5 out of 2 or 0.5 out of 3, because your written response on the diploma are out of 2 or 3 marks. There's 3 of them. Out of 2 and 3. So there's 3 questions, 5 marks each. 2 for part A, 3 for part B, or 3 for part A, 2 for part B. Okay? They don't give 0.5 for a correct answer if it says algebraically, unless you show algebra. Okay? So in this unit, when it says algebraically and it gives you something like this, that means use the formula from your formula sheet. That's what that screams. I would highlight it. I put a little information for myself so that when I see algebraically, I know that means use formula. Because if I give this on a test, a lot of people will just sit and stare at it. They're like, I know I can't just give an answer because she said I can't. I don't know how to do the question. So I star myself if I'm someone who's like, yeah, I'm going to forget that I have to use the formula. And because I've taught this numerous times, I know that's 90% of you. So I would all be starring this, highlighting it. Okay. So the formula is NPR, n factorial over n minus r factorial. We don't need to memorize that because it's on our formula sheet. Okay. Our original question here is n minus 1p2 equals 90. Our first step is always going to be to rewrite it. Rewrite our question. We don't try and work our question out of the question. We rewrite it. Now, this is in the spot of n. This is in the spot of r for our formula, correct? So currently we have this side. We're going to convert it to that side. Okay? So n minus 1 is going to go in for n in this formula. So n is here and here. We agree? So n is the same as n minus 1. So I'm going to get n minus 1 factorial, because that's going in for n, over n minus 1, which is n. That's this. And then I have to minus r. What is r? 2. Factorial. You see how this is n? N minus 1 is actually n. And then I minus r. And what does it equal? Above it, what in the above step does it equal? 90. This is an equation, right? So I'm going to drop the equation down. I work on the left side, work on the right side, put the equal sign where it is. Okay. Then I'm going to get n minus 1 factorial over n minus 3, because 1 minus 2 is 3, equals 90. Now we're back to Friday's lesson. Which one is bigger, n minus 1 or n minus 3? N minus 1. And if we don't remember, we can plug in a number for n. So if we plug in 4, the top would be 3, and this would be 1, right? 4 factorial is bigger than 1 factorial. So this is the bigger one. And we expand the bigger one to match the smaller one. That's our goal, right? So n minus 1 factorial is n minus 1, and then 1 less, which is n minus 2, and then 1 less, which is n minus 3 factorial. And then I'm going to stop there. Why am I stopping there? Because it matches the denominator, and the denominator will be able to cancel off. And it equals 90. That's all the new math. Now we're just doing grade 11. We're just doing grade 11 math. We have to expand it. I'm going to rewrite this leftover. So that it says n minus 1, n minus 2 equals 90. This is grade 11. This is no longer grade 12. So I'm going to have to actually expand them out. N times n squared, n times negative 2, I distribute, I'm going to get negative 2n. Negative 1 times n is negative 1n, so I'm distributing. Negative 1 times negative 2 is positive 2, equals 90. I collect my terms. This is all grade 11. N squared, negative 2n minus 1n is negative 3n. Plus 2 equals 90. In grade 10, we would do, actually grade 10 and lower, we would only have like a variable x or a variable n or a variable a. So you had like 7n equals 35. And then you divide by 7 and you would be done, right? When you have a single variable, you just try and isolate that variable. That's it. We did that in 7, 8, 9, and 10. We've done that through all of junior high and grade 10. Then grade 11 came along, and we had a squared and a variable. So here I have n squared minus 3n. I no longer can just isolate the variable and solve. I can't just like get n by itself and divide by 7 and be done, correct? This is where grade 11 came in. And they said, okay, whenever you have a squared and you have a variable, what do you always have to do? Move everything to one side and set equal to 0. And then you have to factor a quadratic formula every single time. There's no options. People are like, I'm not sure what I do when I do this. Every single time you have a squared and a single variable, you have to move everything to one side, set equal to 0, and then factor a quadratic formula every time. Those are the only options. People are like, but I don't know what to do. I'm like, that's it. You have no other options. So I'm going to subtract my 90 over, and I get n squared minus 3n minus 88 equals 0. The great thing about this unit is your n's can never be decimals. They have to be whole things. Like you can't have like 25.3 people and pick 4 of them, right? So in these cases, your n's are always going to be like 10, 12, 2, 4. If they're decimals, you did something wrong. So we're going to factor. What times what equals the outside 2? So what times what equals 1 times negative 88? So negative 88. And what plus what equals the middle? Negative 3. Remember I told you if you're someone who can't factor, get past denial, go straight to acceptance and come and tell me? And I'll just help you. It's not a big deal. No judgment, ever. All right. So what multiplies to give me negative 88 and adds to give me negative 3? Negative 11 and 8. Yeah. And when we write it out, I know people don't want to do this. What the heck? I got it with my hair, I guarantee you. If I swing my hair, it hits the board and then it picks things up. Okay. The reason why I draw the blanks, it takes about 3 seconds to do that. That's not hard, correct? The reason why I draw the blanks is that it makes it so that I don't make stupid mistakes in factoring. Okay, I think it's negative 11 and 8. Well, let's check it out. Negative 11 times 8 is negative 88. Cool. Negative 11 plus 8 is negative 3. Yes. So I know I didn't mess up. Some people will put 11 and negative 8 by accident, correct? 11 times negative 8, negative 88. Good. 11 plus negative 8 is positive 3. Oh, my signs are wrong. And then I don't make a mistake. Okay? I know it takes an extra probably 5 seconds, but it will get rid of all your errors by drawing the blanks. Okay. We can go straight to product sum because we have a plus 1 in front. We get n minus 11, n plus 8 equals 0. And then in grade 11, we're taught to separate them. So we get n minus 11 equals 0, n plus 8 equals 0. And then we get n equals 11, box it, n equals negative 8, box it. So we technically got 2 solutions. They will have the answer to 11 and negative 8 in your multiple choice. It is wrong, but they will have it. Whenever you get a solution, whenever we have to solve anything, it actually brought me great joy in mathematics. Because I either knew to be happy or cry. There was no in between. Why? Because at this point I didn't just go and send it. I checked my answers every time. You have a question that has a variable in it, correct? Now you have answers of what those variables could be, yes? If I plug them back in and it works, yay! If I plug it back in and it doesn't, sadness or maybe extraneous root, correct? So let's check these out. I plug my 11 in. So I'm going to get 11 minus 1, P2. What is 11 minus 1? 10. So I get 10 P2. Type in 10 P2 into your calculator. What do you get? 90. Anna says we get 90. Correct. So did I send it? No. I found out 90 equals 90. I'm a happy camper. I'm like, dang, I did good. Yay. If it doesn't work, I'm like, dang, what's wrong? Is it extraneous? Or did I mess up? Right? So this one's good to go. Put myself check mark. Yay. Now I'm going to check negative 8. I get negative 8 minus 1 P2. So I have equals 90. Then I have negative 9 objects. I'm going to pick 2 and arrange them. Does that even make sense? I have negative 9 objects. P means I arrange them. So I have negative 9 objects. I'm going to arrange 2 of them. Does that make any sense in your brain? No. Your N and your R can't be negative. You can't have negative objects and pick something. You can either have objects or not, right? So this doesn't even make sense. If you bring it to your calculator, it's going to get mad at you. So this is the solution. N equals 11. Check mark says N is right, correct? N equals negative 8 is a solution. It's just not correct. It just doesn't work. It is outside the scope of the answer. It is a solution. Some people are like, is it a solution? Yes, it is a solution. So you can't write no solution. It is a solution. It just doesn't work. So I don't write no solution. I say I reject it. How do I reject it? I say not today. It's not right. And what must I write still? Extraneous. Yeah? Makes sense? Okay. Because we have a little bit of extra time. We're going to move on to a whole new lesson in a second. But for right now, I will give you till the 8th to try 3A and B. There for homework. I'll give you that much time to work on it. It's about 8 minutes. So, what we're going to talk about is permutations with restrictions continued. We've had this already. We're just going into more advanced restrictions. And then tomorrow we'll talk about what happens if our words have repetition. Because as of right now, you may not have noticed this, but I've never given you a word that has a repeating letter. So I didn't give you pool or loop or popple or pizza, right? I haven't given you any words that have double letters. Yeah, okay, why? Okay. So, oh, this is a debacle. It's not gonna work. My genius plan has been foiled. Okay. Whatever. It falls, it falls. Okay. So we have the letters in the word kitchen. So what I'm going to get you to do every single time, which right now seems stupid, is to write out the letters. So I'm going to go K, I, T, C, H, E, N. And some people would be like, Lepp, you wrote out the word again. Cool. If I just end up rewriting the word, that means that there was no doubling letters. Okay? And we do this every single time because when we have repetitions, we have to have an extra step that we have to do. And bye. And then writing out the extra step reminds you to do the repetition. So for example, if I had the word popple, say that was written out for me, typed for me, when I would go to rewrite it, I would rewrite it as P-O-P-P-L-E. So this would remind me that there are 3 P's that are the same, and it would be like, hey, there's that extra step. Or if not, you're like, why did I write them out like this? This is so stupid. Oh, there's an extra step. It reminds you to do the extra step, okay? And some people are like, I don't need to do that. And then the test comes, and you don't do the extra step, and you didn't write out the word, and then I just stand all sad and kind of disappointed. Like that's it. So please listen to me. I don't tell you to do anything just because I want your pencil to do extra work or you to have less lead. I do it because I know with practice and enough times teaching it that that's a common error you make, and this fixes the error. Okay? If you just follow, come on, you think, oh, all of you will follow. Okay, so we have the word kitchen. So here it says letters K, C, N must be together, but not necessarily in that order. So we have K, C, and N have to be together. Not necessarily in that order, correct? It could be NCK, it could be NKC, it could be all out of order. And then these letters have no restrictions. They just don't have to be together with K, C, and N. Okay? We'll leave that there for a second. Okay. How do we do that with blanks? Well, how many letters are in kitchen? There's 7, so I'm going to put 7 blanks. Now, words don't have to say that we can't repeat the letters because they're telling you they gave you the word kitchen, just like I just gave you the word kitchen. Here it is. Okay? I gave you the word kitchen. Is there an unlimited amount of K's or is there 1? There's 1. It's like having sticky notes with the word kitchen on it or Scrabble tiles with the word kitchen on it. That's all you have. So the moment you put a K down, it's gone. So I have to box and hold. Remember we talked about boxing and holding when you can't repeat? That's what we're going to have to do. Now, when it says that they must be together, the first thing I do is hook them together. So 3 letters that have to be together. So I hook them together at the front. That's how I always start it. So K, C, and N have to be together, but not necessarily in that order. So for the first blank, I can have K, C, or N. True statement? How many options is that? 3, so always list the number of options above. Then because I'm not allowed to repeat, I have to keep something behind, I box and hold one of them. So let's pretend I box and hold the K. Then what do I have left for this blank? C and N, which is 2 options. Now someone said to me, do I have to write all the letters below to get full marks? No, you don't. If you've done it enough, you often don't even have to write the letters, but it helps to learn it. So that's what I do. Okay? So we have a C and an N. Let's pretend I hold the N. What option do I have left for this one? C, which is 1. I hold the C. Now these 3 are done. How many letters do I have left for the remaining 4 spots? 4 letters, correct? I, T, E, and H. So I have I, T, E, and H, which is 4 options. Hold the H, then I would have I, T, E, which is 3 options. Then I, T, which is 2. And then I, which is 1. And then I have to remember to multiply. We agree? Now this is K, C, N together at the front, is it not? Is that what it wanted? Did it want KCN together at the front? Sometimes it asks that, and we'd be done. If it said KCN together at the front, done. Correct? But it says KCN together. So can you guys all put your pencils down because I need all the brain matter that you have. And I don't want you writing anything. So currently, we have 3, 2, 1, 4, 3, 2, 1. And we know that this 3, 2, 1 has to stay together. Yes? Okay. So let's pretend I hold my letters here. I had K, C, N, and then I don't remember what letters I picked. What did I pick for these ones? Oh no, I went K, N, C. It doesn't matter. I, T, E, H. Let's say, correct? Pretend those are the letters that are sitting in front of us. If I took KCN now, and I write it like this, I'd have KCIT. It's a different word, correct? What happens if I take this KCN, and I move it between the I and the T? Would it give me a new word? It'd be I, KCN, TEH. Is that a different word? Is KCN still together? Yes. So that would look like this. 4, 3, 2, 1, 3, 2, 1. And that would be I, KCN, TEH. Do we agree? So that's case 1, where they're still together. This is case 2. Case 3, I could now move them between the T and E, correct? So now I would have 4, 3, 3, 2, 1, 2, 1. So I would have I, T, KCN, EH. Is that a new word? Yeah, that's case 3. Then I could move it between the E and the H. So I would have 4, 3, 2, I, T, E, 3, 2, 1, which is KCN, and H, which is case 4. And then people forget about the last case. I could completely put the KCN behind all of those letters and make a totally different word, would it not? I, T, E, H, KCN. Now the question for you, if I go 3 times 2 times 1 times 4 times 3 times 2 times 1, or I go 4 times 3 times 2 times 1 times 3 times 2 times 1, or I go 4 times 3 times 3 times 2 times 1 times 2, 1, does it get me, what the heck, I put an H, this is a disaster. And I multiply those ones, or I multiply these ones, do I get a different answer for each case, or is it the same answer for every case? Same answer, correct? Because commutative property of mathematics, 3 times 2, 2 times 3, same answer. Yes? So, would it be better to list every single case, or be able to determine how many cases there are and just multiply by it? Determine the number of different cases, correct? So we're going to go back, you can pick up your pencils. Let's go and say, how the heck can we determine the number of cases? Well, this is one case. The case that's currently there, that's one case, correct? And then I have to see how many times I can place it between different letters, correct? So that's one case. Or I could put it between these two letters, which is 2 cases, 3 cases, 4 cases, 5. Did you know that it'll always be one more than the hooked together numbers? The last of the hooked together? So if I have these hooked together, then the red is the KCN. Okay, these are hooked together. These are my open letters, I, T, E, H, yes? So they can be here, which is one way. Here, 2 ways. 3, 4, 5. Is it not? If I had 5 open letters and this was my hooked together letters, how many cases would I have? 1, 2, 3, 4, 5, 6. Correct? If I had 3 letters left, and these were my hooked together, how many cases would I have? 1, 2, 3, 4. So it's always one more than these ones that are sitting here. If I have 5 that are open, I have 6 cases. 4 that are open, 5 cases. 3 that are open, 4 cases. 2 that are open, 3 cases, right? So this one has 4 letters open. 4, 3, 2, 1. So how many cases am I going to have? 5. It's always one more than this number after the hooked together numbers. Does that make sense? Because if I have 4, I have 5 places I can put around those 4 letters. If I have 5, I have 1, 2, 3, 4, 5, 6 places I can put it around them. Make sense? So it'll be this. I need this on the lanyard. Okay. Times 5. And I put multiplied by 5 at the end to prove a point that I don't have 5 letters or something. That's actually 5 cases that come out with the same answer. Now this is where I'm going to make this mind blown for you. Pencils down again. And I have to have pencils down because I know this goes badly. Okay, 4, 3, 2, 1 times 5. Those are all multiplied, yes? And we agreed that if I take all those numbers and I mesh them all around, I still get the same answer because multiplication doesn't matter order, correct? Like 3, 2, 1 times 1, 2, 3 times 2, 1, 3 all gets me 6, yes? Okay, so a lot of people want to tell me, well, this is 3 factorial, 4 factorial times 5, which is true. They're going to give a different answer, though. What they'll do is they'll rearrange this, because what is 4 factorial times 5, actually? 5 factorial. Because can I rearrange this? Can I go 3, 2, 1, which is 3 factorial, we all agree, correct? Can I reorder this 4, 3, 2, 1 times 5? Can I rewrite it as 5, 4, 3, 2, 1? Multiplication, can I move multiplication around? Can I go 3, 2, 1, 1, 2, 3, 2, 1, 3, 1, 3, 2. These all equal 6, do they not? Is that a true statement? So can I rearrange these to be 5 times 4 times 3 times 2 times 1 and say it's 5 factorial? Can I not do that? That will always work. Why does it always work? Well, let's think about this. I told you that if you have hooked together 4, 3, 2, 1, and then I have 6, 5, 4, 3, 2, 1, and I said they have to be together, what am I going to always multiply by? What am I going to multiply now? 7. Because it's always one more than this, is it not? Yes? If I move this 7 in front of here now, what do I actually have? 7 factorial. So that number will always be able to come in front and join because it's always one more than that number. We agree? Now, if it's just a good old multiple choice, could I not just go 3 times 2 times 1 times 4 times 3 times 2 times 1 times 5 and get an answer? Yes. I'm preparing you for if they give it to you in a weird way. If they say this can be written in the form a factorial, b factorial, where a is less than b. Then you're like, cool, I can write it in the form 3 factorial, 4 factorial, 5. And then you're like, 3, 4, where does the 5 go? Some people just like, I'll omit it. And they put 3, 4 as their answer. Can that be the way that you can do it? No. Instead of writing it as 3 factorial, 4 factorial times 5, we can write it as 3 factorial for the 3, 2, 1, and then 5, 4, 3, 2, 1 is 5 factorial, and then it has to be 3, 5, right? If you wrote it out of order, some people will say, well, why can't I give 5, 3? Why can't you give 5, 3? Yeah. A has to be less than B. So is 3 factorial, 5 factorial the same as 5 factorial, 3 factorial? Yes. That's true, right? 3 factorial times 5 factorial is the same as 5 times 3. That's true. But they forced it for A to be less than B, because I wrote it like that, didn't I? So which one has to come first? The 5 or the 3? The 3. So your answer would be 3, 5. Do you see what I'm saying? 99% of the time, it's just like punching in numbers and you get an answer. But I want you prepared for 100% of these questions. I don't want you prepared for 98% of the questions. I want that when I see the diploma, it's possible for you to get 100. Do I care if you get 100? No. But I'm disappointed in myself if I see questions on there that I'm like, my kids can't do. Then I failed you. That's how I feel. If I have taught you all the things, A factorial, B factorial, you know A has to be less than B, you've been prepared for that, you can get 100. Will you get 100? Probably not. But could you? That's all I care about. You're capable, I've taught you enough to get 100. Do you get one? Yeah, it's hard to get 100. Really hard. It's hard to not make an oopsie. I would have never run 100 on any of my diplomas. I would have made a mistake, or 10, or 20. On my diplomas. Okay, does that make sense? What's the answer to that one?
I think it's 720 actually.
Okay. Once you have that written down, pencils down, we're having another big discussion. If I wanted the fastest way for you to tell me how many people are in this school but not in this class. So if I just said to you, how many people are not in this class? I just walked up and said, okay guys, quick answer, how many people are not in this class? Would the fastest way be to put an announcement over the intercom and be like, everyone, you're a statue. Do not move. And then you walk from classroom to classroom and you count. And then you count. And you creep the bathrooms. You're like, how many of you are in there? And then you go to the attendance lady and you're like, how many people are missing right now? And then you add them all up and then you find out how many people are not in this class. Is that the fastest way? No, you're probably going to miss a couple people. Or 10, right? What is the fastest way, if I just said to you, I don't want the answer, I want you to tell me, how would you figure out how many people are not in this class? You're allowed to talk to other people. You're allowed to talk to people in this. Like you are allowed to talk to other people right now, but you're also thinking this in your head. I'm allowing you to pretend that you could get up and you could ask Mrs. Atkinson a question or the attendance lady a question. Discuss. How would you figure out how many people are not in this class? That was counting every single person. Okay, fastest way. Anyone have any ideas? Yeah, get the total amount of people here in this school. Just say, hey, can you help me out, sister? Tell me how many people are in the school. And she'd be like, 1,060. I think that's approximately how many are in the school. And then, which is insane, just so you know. And then I would say, oh, there's 25 of you. However many there are. And you subtract them. And poof, you'd have the people not in this class. Would you not? Okay, let's take that answer and use it for the next question. Again, adding some random. This is my go-to. Number of ways the letters in the word kitchen can be arranged if the vowels must not be together. I would highlight this question like it's going out of style, because there will be a test question like it. And you're like, oh my goodness, she's telling us it'll be on the test, and you still do terrible on it. So please prove me wrong, okay? Highlight star, 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 star. Remember, question like this. I don't really care. You can even say there will be a question like this, because there will be. It's not going to be a shock. And you'll be like, oh, she told us, but I still can't do it. We don't want that. We want you to be able to answer it, get full marks, okay? So this one says the vowels can't be together. What is the opposite of the vowels not together? Vowels together, correct? If I take two opposites and I add them up, I'll get the total of all the options, won't I? Right? So if I take the people not in this class and I add it to the people in this class, I get the total number of people in this school. We agree? True? So if I take all the cases of the vowels not together and I add the vowels together, I would technically get the total number of words I could get out of this whole thing. We agree? So what if I subtract? So let's do total number of words I can get from kitchen. And I use words loosely, because we're not bringing out a Scrabble book seeing if it's a real word, correct? It's different looking items. Yes? How many letters are in kitchen? 7. If I have absolutely no restrictions, so this is total number of words, no restrictions. If I have no restrictions, I can start from the left, work my way to the right, correct? How many letter options would I have for the first blank if there's no restrictions? 7. What did I tell you about words? You always have to box and hold something, correct? Because we don't have unlimited letters. We have 7 letters. Yes? So let's pretend I keep the K here. How many would I have for the next blank? 6. Say I keep the I. Then 5. Say I keep the T. Then 4. See, I keep the C. Then 3. I keep the H. Then 2. Then I have the N left over, right? That's fine. So that's one option I can make out of the word kitchen. Kitchen, right? Now, 7 times 6 times 5 times 4 times 3 times 2 times 1 is the same as 7 factorial. We agree? Which is actually 5040, fun fact. So every 7-letter word that has no repetition can make 5040 different words. It's crazy, hey? So if you had to try and like draw out the cases, you're going to miss a couple. It's 5040. You need quite a few sheets of loose leaf. Try and figure that out. Okay? So I told you the maximum number of kids in this school is 1,060 total. Can't get 1,061. Won't have 1,059. We have 1,060. It's not changing. We agree? The number of different words I can make out of kitchen is 5,040. I can't find another new case. There's not 5,041 options. There's 5,040. I don't have 5,039. I don't have 5,041. I have 5,040 different words I can make. We agree? That makes sense to you? Okay, so if I take the total number of words with no restrictions, that's all the maximum words I can make, and I take off the vowels together. I take out all the cases where the vowels are together. So I take off all the cases, 5,040 total, and I take out all the cases where the vowels are together. What's left over? What's the opposite of vowels together? Vowels apart. Vowels not together. We agree? So whenever it asks you for something to not be together, you don't actually find it not together. You take the total, you subtract off the opposite, which is the vowels together, and what's left over are the vowels not together. Which is what you guys told me you would do if I wanted the kids not in this class. You didn't go and find the kids not in this class. What did you do? You took the total and you subtracted off the opposite of not in this class, which is people in this class. So you took the total, you subtracted off the kids in this class, and what was left over was the kids not in this class. So when I want not vowels together, I take the total number of words from kitchen, I subtract off all the vowels together cases, I huck them out, and then what's left over? The vowels not together. It's opposite case. Does that make sense? All right. So vowels together. 1, 2, 3, 4, 5, 6, 7. How many vowels? This is a subtraction sign. Make a different color. How many vowels are in kitchen? 2. I and E. Correct? So I'm going to hook them together. So I have 2, then 1. Do we agree? Use up those 2 vowels. How many letters do I have left? 5. Then 4, then 3, then 2, then 1. And then am I done? That represents vowels together at the front. But I want all the cases where vowels are together. So what do I still need to multiply that by? 6. Because there's 6 cases where the vowels are together, remember? We can move them. Here, which is one way. Here, which is, so here's 1, here's 2, here's 3, here's 4, here's 5, here's 6, and it's always one more than that number, right? So times 6. So we're going to have 5,040 minus, when you multiply that together, you get 1,440. So there are 5,040 different ways I can rearrange kitchen. There are 4, of those cases, 1,440 have the vowels together, right? I take that 5,040 and I subtract off the 1,440. I have all the cases where the vowels aren't together, which I believe is 3,600. Schedule somewhere. I'll find it. Okay. Flip over. I want you guys to try this one.